Number 4 is so much like number 3 that it's not really worth going over. Notice we use a Kb because we know that NH3 will act as a base, again, because of the lone unbonded valence pair that we talked about before that can accept another H plus. So here it is doing that. We also talked about that you need to write water as a reactant here so that we show where the H comes from. And why that's important is because if you just write H plus, then you just end up with NH4, and then you don't have an OH minus or H plus molarity to talk about so that you can find your pH, or in this case, POH. Other than that, it's basically number 3 repeated. Number 5 has a bit of a trick to it. We know that sodium will come off its anion in water, so let's just disregard that. This molarity then is the molarity of the anion, and what we need to realize is that this is acetate, and it can create acetic acid, right? It is the anion in acetic acid, which is not a strong acid. So that means that acetate does have some appreciable ability to pick up H plus. I mean, it doesn't have any to give. And before somebody shouts, look, they're right there, those are not the H atoms that we're talking about. Those are not acidic. Those are very tightly held. Go look up the Lewis dot structure for acetate. And when it's an acid, we write it like this with the acidic acid, the acidic H plus off to the side so that we can appreciate that this is an acid, that this is the acidic H and that's the anion. So what we've done effectively is dumped in the anion of a weak acid. What will it act like? It will act like a base and create the acid. What will happen is this one here, right? Now, did they give us Ka or Kb? We know Ka from previous problems, fine. But we know that what this is going to do is act as a base. This is the reaction I need. Ka does me no direct good. I have to use it. Remember this problem here? I have to use it to divide into Kw to get Kb. Kb will be this. And now I can set up an ice box with the anion plus water yields the acid and the OH minus. Water does not have a molarity in water. It's a liquid, so its molarity is non-existent. After that, it's basically a repeat of 3 and 4 with a weak acid or base, in this case a weak base. And again, we can disregard the X because it's too small to matter, the minus X.